Let's try another couple problems. And at that point, I'm going to say you're probably going to be an expert on kinematic motion graphs. Okay, so what do we got here? Which graph best represents the relationship between acceleration of an object falling, the acceleration of an object falling freely, ooh, there's a big hint right there, falling freely, near the surface of the Earth, and the time that it falls. So it turns out the time that it falls isn't really that important. What is the important thing there is falling freely. If something is falling freely, what do we know about its acceleration? Okay, what we know is that it is falling at 9.81 meters per second squared, probably with some sort of negative number, but we don't need to worry about that so much. We really just have to remember that it's falling that fast, or that acceleration, and it's constant. Okay, so I want something, since all of these are acceleration, I don't want a graph that has decreasing or increasing acceleration. I want something with a straight line. So this is the only possible answer. Because if it's falling constantly, or falling freely, that means it has to have a constant acceleration of 9.81 meters per second. All right, which pair of graphs represents the same motion of an object? So I have displacement versus time, I've got velocity versus time. So this one is some sort of velocity that is, it's a constant velocity, it looks like, but it is decreasing, right? Or is it probably a constant acceleration, I guess we would say. But in this case, this thing is starting out at some sort of a negative velocity, and then it's going and increasing to some sort of positive velocity, so that can't work. This one you have constant velocity, this one you have velocity which is going up, 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 and slowing, and then going into the negative direction, and then it's speeding, speeding, speeding up, so that can't work. All right, this one here, constant velocity, but in the positive, only in the positive side, so it's above here, so all of the velocity is positive. This one you have it below the x-axis there, so it means that this one has to be some sort of negative velocity, or it has to have a direction which is negative, and so there's no way these two can work. And this one, you think, well, does this look right? But when you really look at it, look what I have here. I have a constantly increasing velocity. So a constantly increasing velocity implies that it's accelerating. Acceleration. Okay, and what do we just say about acceleration? Acceleration on a displacement time graph is exponential. So these two, those are your answer. Okay, two more and we're done. The graph below represents the velocity of an object traveling in a straight line as a function of time. Velocity versus time. Determine the magnitude of the total displacement of the object at the end of the first 6 seconds. So I'm looking for something right here. So it wants displacement, so that's meters. And then I look at my x, or my y, and I look at my x, and I realize, hey, look at this. Meters divided by seconds times seconds equals meters. If you take y and you multiply it by x, and it equals what you want, it's area under the curve. Okay, so how do we do that? We have the total for the first 6 seconds. I have two parts. I'm going to break this down into two different parts. And on this one, I'm going to do 1/2 times 2 times 10, the triangle formula, right? All I have to do is take 1/2 of the base times the height, and so it's going to be 2 times 10 is 20 times, so 1/2 times 2 times 20 is 2 times, oh, I'm sorry, times 10 is 20, so 1/2 of that is equal to 10 meters. Okay, and then I'm going to grab this little component. This one I have 2, 4, 6, so that's 4, and it's a square, so it's just length versus width. So 4 times 10 is 40, so plus 40, that's 50 meters. Okay, look at something really quickly here. Yes, I got the part done. Okay, last part. Which graph best represents the motion of a block accelerating uniformly down an inclined plane? We talked about this at some length, right? I've already talked about this 3 times. I have distance versus time. distance versus time, distance versus time, distance versus time. Okay, if it's accelerating, it means that there has to be some sort of exponential curve. Okay, this is a constant velocity. Constant velocity, it means that the distance and the slope of the distance tells us that the velocity is not changing. It's just based upon distance divided by time. This is no velocity because the distance does not change over time. If you have a constant velocity, no acceleration. If you have no velocity, no acceleration. This one is, I have a constant velocity and then no velocity, but again, there's no change in velocity really, other than the fact that it's going to zero, and that is not going to help us with acceleration. I'm looking for this. All right, there you go. That should get us through most of the possibilities for motion graphs.